Hello everyone. In last classes we have discussed about the electric field at an axial point due to an electric dipole. Okay, and we also discussed the electric field at any point on the equatorial line due to an electric dipole. Okay, so we'll do some numericals. Suppose we have an electric dipole of charges plus minus 10 microcoulomb and their separation is 5.00 millimeter. Okay, that means we have an electric dipole. Suppose this is negative charge, this is our minus 10 microcoulomb, and this is another charge of plus 10 microcoulomb, and they are separated by a distance of 5.00 millimeter. 5.00 millimeter. Okay, so O is the center of this electric dipole. So you need to calculate the electric field on the axial line at a distance 15 centimeter on the side of the positive charge, So the distance from center O to point P is suppose 15 centimeter. Suppose this is the point P, which is at a distance of 15 centimeter from the center O, and this is any point on the axial line. In this question we need to calculate the value of electric field at this point due to this electric dipole. Okay, P is any point on this axial line. The point P is at a distance 15 centimeter from the center O, and at point P we need to calculate the value of electric field, okay, due to this electric dipole. Here the charges are plus minus 10 microcoulomb, and their separation is how much? Their separation is 5.00 millimeter. Okay, you remember the formula. Electric field at axial point due to an electric dipole is 1 by 4 pi epsilon naught twice P divided by R cube. So this is the electric field at any point on the axis of the dipole due to an electric dipole. Okay, so here the P is what? P is the dipole moment. P means it is the product of either charge and separation between them. Here charge is how much? Charge is 10 microcoulomb, 10 into 10 to the power minus 6 coulomb. And what is twice A? Twice A means the distance between two charges, which is equal to 5.0 millimeter. So it will be 5.0 into 10 to the power minus 3 meter. Okay, if you multiply it, then you'll find the value of the dipole moment. So it will be 5.0 into 10 to the power minus 5. This 1 minus 6 plus 1, it will be minus 5 minus 3 minus 8 coulomb meter. Okay, the value of dipole moment is 5.0 into 10 to the power minus 8 coulomb meter. Okay, now we need to calculate the electric field at that point. Electric field at that point will be what is the value of 1 by 4 pi epsilon naught? The value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Okay, and the value of P is how much? 5.0 into 10 to the power minus 8 divided by R cube. R is the distance from center to the point P. Here R is how much? R is equal to 15 centimeter. That means 0.15 meter. So it is 0.15 whole cube. Okay, so it will be 2 9s are 18 into 5.0 into 10 to the power 9 minus 8 will be your 10 to the power 1, or it is 15 cube into 10 to the power minus 6. 10 to the power minus 6. Okay, if we simplify, the answer will be 2.66 into 10 to the power 5. 2.66 into 10 to the power 5 Newton per Coulomb. Okay, the value of electric field at point P on the axis of the dipole, which is at a distance of 15 centimeter from the center of the electric dipole, is how much? 2.66 into 10 to the power 5 Newton per Coulomb. So it is very simple. So we have given an electric dipole of charges plus minus 10 microcoulomb, and they are separated by a distance of 5.00 millimeter. Here we need to calculate the electric field on the axis of the dipole at a point which is at a distance 15 centimeter from the center of the electric dipole. Okay, and the point P is on the side of the positive charge. You remember the question, in the question it is given here the point P is on the side of the positive charge. Okay, so that is why I am taking the point P on the side of the positive charge, and we have already calculated the value of electric field at any point on the axis of the dipole, which is equal to what? 1 by 4 pi epsilon naught twice P by R cube. P is the dipole moment, which is equal to P means what? It is the value of dipole moment, which will be equal to either charge and separation between them. So Q is what? Q is your 10 microcoulomb. That means 10 into 10 to the minus 6 coulomb, and twice A means the separation between two charges, that which is equal to 5.00 millimeter. That means if you want to convert into meter, it will 5.0 into 10 to the power minus 3 meter. Okay, if you multiply it, then this will be the value 5.0 into 10 to the power minus 8 coulomb meter will be the dipole moment. Then the value of electric field will be your this one. Okay, in this question there is another question. We need to find the electric field on the equatorial point also, on any point on the equatorial line. Suppose this is our electric dipole minus 10 microcoulomb and plus 10 microcoulomb, and they are separated by a distance of how much? They are separated by a distance of 5.00 millimeter. Okay, this is our equatorial line. This is our equatorial line. On the equatorial line, here P is any point, and the point P is at a distance of how much? Suppose the point P is at a distance of 15 centimeter. 15 centimeter. Okay, at point P also, we need to calculate the value of electric field. We need to calculate the value of electric field. Okay, you remember in last class we have discussed the electric field at any point on the equatorial line. Okay, and the value of electric field at equatorial point, at any point on the equatorial line, is how much? 1 by 4 pi epsilon naught P divided by R cube. Okay, this is the value of electric field. This is what? This is the value of electric field at any point on the equatorial line. Okay, so here P also how much? P is the electric dipole moment, and the value of P we have already calculated, which is equal to 5.0 into 10 to the power minus 8 coulomb meter, and R is what? R is the distance from the center O to the point P. Here R is how much? R is equal to 15 centimeter. So the answer will be, in place of 1 by 4 pi epsilon naught, we can take 9 into 10 to the power 9. 9 into 10 to the power 9. And what is P? The value of P is equal to your 5.0 into 10 to the power minus 8, okay, divided by R cube. R is how much? R is the distance from center O to the point P, which is equal to 15 centimeter. That means 0.15 meter. Okay, if you calculate this one, the answer will be 1.33 into 10 to the power plus 5 Newton per Coulomb. Okay, Newton per Coulomb. So this will be the answer. That means at the equatorial point P, the value of electric field will be equal to your 1.33 into 10 to the power 5 Newton per Coulomb. Okay, this is the answer. This question is from textbook, example number 1.10. Example number 1.10. Okay, this is from textbook 1.10. Okay, we have another question. So I am repeating the questions answers again. Suppose we are given an electric dipole of charges plus minus 10 microcoulomb and they are separated by a distance of 5.00 millimeter. Okay, this is our electric dipole, minus 10 microcoulomb, and this is our plus 10 microcoulomb, and they are separated by a distance of how much? 5.00 millimeter, and we need to calculate the electric field on the axial line at a distance of 15 centimeter from the center of the dipole on the side of the positive charge. Okay, this is the formula. This is the formula for the electric field at any point on the axial line. Okay, here P is the dipole moment, which will be equal to either charge and separation between them. Okay, if you solve this, the value of dipole moment is how much? 5.0 into 10 to the power minus 8 coulomb meter, and we put the values of this dipole moment P and R, they will find this answer. Okay, and on the equatorial line, this is the value. Okay, now the next question is, in last classes we have already discussed the torque on a dipole in an uniform electric field. Torque on a dipole in an uniform electric field. Okay, suppose we have an uniform electric field. An uniform electric field is also represented by some parallel lines. Parallel lines. Suppose this is an uniform electric field. This is the uniform electric field. Okay, E is the uniform electric field, and on that uniform electric field, we have considered an electric dipole. We have considered an electric dipole. Suppose this is minus q and this is our plus q, and they are separated by a distance of twice a. Okay, so what is the torque acting on the dipole? Okay, the two forces will be acting on the two charges. One on the charge, on negative charge, the force is along this direction, and on the positive charge, the force is along on this direction. Okay, and due to these two forces, the electric dipole will rotate. That means the electric dipole will rotate, means a torque will exerted upon that electric dipole, and the value of the torque is how much? The value of torque is tau is equal to Pe sin theta. Pe sin theta. What is P? P is the dipole moment of the electric dipole, and E is the value of electric field, and theta is the angle between electric field E and the dipole moment P. Okay, so let us do a numericals. Suppose we are given an electric dipole. So we are given an electric dipole which is in an uniform electric field. Okay, this is suppose a uniform electric field. This is an uniform electric field. Okay, on this uniform electric field, an electric dipole is held. An electric dipole is held at an angle of 30 degree. An electric dipole is held at an angle of 30 degree, and the magnitude of electric field is how much? Magnitude of electric field is 10 to the power 4 Newton per Coulomb. The magnitude of electric field is 10 to the power 4 Newton per Coulomb, and we are on that electric field, an electric dipole is held at an angle of how much? Electric dipole is held at an angle of 30 degree. That means this electric field, on that electric field, this electric dipole will make an angle of 30 degree, and the torque acting on that electric dipole is also given. The torque acting on that electric dipole is how much? It is 9 into 10 to the power minus 26 Newton meter. 9 into 10 to the power 26 Newton meter. Okay, so in this question we need to calculate the electric field. We need to calculate the dipole moment P. we need to calculate the dipole moment P. So on this uniform electric field of magnitude 10 to the power 4 Newton per Coulomb, okay, an electric dipole is there which is held at an angle of 30 degree, which is held at an angle of 30 degree, and the torque acting on that electric dipole, is how much? 9 into 10 to the power minus 26 Newton into meter. Okay, we need to calculate the dipole moment of the electric dipole. Okay, these are given and we need to find the value of P. P is what? Electric dipole moment. Okay, so we know that the torque acting on an electric dipole tau is equal to Pe sin theta. Pe sin theta. Okay, and the value of P will be equal to tau divided by E sin theta. E sin theta. And what is the value of tau? The value of tau is equal to your 9 into 10 to the power minus 26. And what is the value of electric field, which is equal to 10 to the power 4 Newton per Coulomb. And the value of sin theta, theta is how much? Theta is equal to your 30 degree. Okay, so 9 into 10 to the power minus 26, 10 to the power 4, sin 30 means half. Okay, so it will be your 18 into 10 to the power minus 30 Coulomb meter. Okay, 18 into 10 to the power, or you can write it 1.8 into 10 to the power minus 29 Coulomb meter. This is the value of electric dipole moment. Okay, it is very simple. On an uniform electric field, we are given an electric dipole which is held at an angle of 30 degree, and the magnitude of electric field is how much? It is 10 to the power 4 Newton per Coulomb, and the torque acting, we know that the torque will be acting on that electric dipole, and the amount of torque acting on the dipole is how much? 9 into 10 to the power minus 26 Newton meter. We need to calculate the value of dipole moment. Okay, we have a formula. The formula is the torque acting on that dipole is tau is equal to Pe sin theta. Okay, the P will be equal to your tau divided by E sin theta. If you solve this, you will find the dipole moment of the electric dipole will be 1.8 into 10 to the power minus 29 Coulomb meter. Okay, it is very simple. Now we discuss the next topic is electric field lines or electric lines of force. Electric lines of force. Okay. So what are these electric lines of force? Okay. Suppose we have a point source. Okay. Suppose we have a point source Q. Q is a point source, and this is the electric field of that point source. Electric field means the region surrounding the point sources in which it can exert some appreciable amount of force. Okay, the source Q will exert some appreciable amount of force inside this field, and beyond this field it will have no influence. Okay, if any positive source comes inside the field, it will repel, and if negative source comes inside the field, it will attract. But if any positive source is outside the field, then there is no influence on that point source. Okay, so electric field means the region surrounding the point sources in which it can exert some appreciable amount of force. Okay, suppose this is a point source and this is the electric field of that point source. Okay, if we take a point sources, very small magnitude. Suppose we have considered a test source Q naught at this point. If you consider a test source Q naught at this point, okay, and the point source is free to move on that electric field. The point charge is free to move on that electric field. Okay, this positive charge Q will repel the point charge in this direction. The positive charge will repel that test charge in this direction. That means this point charge will follow a path. The point charge will follow this path. Okay, this arrow is known as the electric lines of force. Electric lines of force. That means electric lines of force is the path followed by a test charge in an electric field. Okay, what is electric lines of force? Electric lines of force is the path followed by a point charge or path followed by a test charge inside an electric field. Okay, if it is free to move inside that electric field, that means if we take the same test charge at this point, if you consider the same test charge at this point, this plus Q will repel this test charge in this direction. That means the test charge will move in this direction. Okay, the test charge will move in this direction. Okay, this direction is the electric lines of force. Okay, if you consider the same test charge at this point, this plus Q will repel this point charge in this direction. That means the point charge Q naught will follow this path. Okay, this path is known as the electric lines of force. Okay, so electric lines of force means the path followed by a test charge inside an electric field. Okay, when you free the test charge, okay, when you free the test charge, okay, so it's very simple. What are the electric lines of force? ये जो इलेक्ट्रिक लाइंस ऑफ फोर्स है, ये क्या है? अगर इलेक्ट्रिक फील्ड के अंदर किसी भी टेस्ट चार्ज को किसी भी पॉइंट में रखो, अगर वो जो डायरेक्शन लेता है, जिस डायरेक्शन में वो ट्रेवल करता है, वही डायरेक्शन होगा इलेक्ट्रिक फील्ड लाइंस. ओके, दैट मीन्स इफ यू कंसीडर्ड ए पॉइंट चार्ज, इफ यू कंसीडर्ड ए टेस्ट चार्ज एट दिस पॉइंट, इस पॉइंट पर अगर रखोगे एंड दिस पॉजिटिव चार्ज विल रिपेल दिस test charge in this direction, that means this test charge will follow this path, and this path is known as the electric field lines. Okay, and you remember electric field lines are always start from positive charges. Okay, suppose if you have a single positive charge, suppose this is our single positive charge. Okay, from this positive charge electric field lines will be emerged out like this. From positive charge, the electric field lines will start. Okay, electric field lines will start. And if you have a single negative charge, okay, the electric field line will be finished at this negative charges. Electric field lines will finish at this negative charges. So you remember, electric field lines always emerges from the positive charge. Okay, and finished at this negative charge. इलेक्ट्रिक फील्ड लाइंस कहाँ से निकलता है? पॉजिटिव चार्ज से निकलता है. ओके, तो इलेक्ट्रिक फील्ड लाइन पॉजिटिव चार्ज से डाइवर्ज होता है. दैट मीन्स इलेक्ट्रिक फील्ड लाइंस कहाँ से निकलता है? पॉजिटिव चार्ज से निकलता है. और वो फिनिश कहाँ होता है? इट विल फिनिश ऑन ए नेगेटिव चार्ज. ओके, इफ यू कंसीडर ए सिंगल पॉजिटिव पॉइंट चार्ज, फ्रॉम दैट पॉजिटिव पॉइंट चार्ज इलेक्ट्रिक फील्ड लाइंस विल बी इमर्जिंग आउट लाइक दिस. And if you consider a single negative charge, the electric field line will be converging like this. That means positive charge से electric field lines निकलता है और negative charge में क्या होता है? Electric field lines finish होता है. Okay, if you consider an electric dipole, अगर एक electric dipole लोगे तो वो क्या होगा? Suppose if we consider an electric dipole, suppose positive charge and this is our negative charge. Okay. The electric field lines are starting from positive charge and finished at negative charge. So it will be, the electric field lines are look like this, starting from positive and finished at negative charge. So these are the electric field lines. These are the electric field lines, starting from positive and finished at negative. Starting from positive and finished at negative like this. Okay, so you can see electric field lines are starting from alloy starting from positive चार्ज से इलेक्ट्रिक फील्ड लाइंस निकालता है और वो कहाँ फिनिश होता है, निगेटिव चार्ज में फिनिश होता है. एंड इलेक्ट्रिक फील्ड लाइंस इज द इमेजिनरी लाइंस ऑफ फोर्स along which a test charge will move. Okay, if you free to move them the test charge, if you free to move them, move the test charge. Okay, that means ये जो इलेक्ट्रिक फील्ड लाइंस है ये क्या है, ये टेस्ट चार्ज का, ये यूनिट टेस्ट चार्ज का ये पार्ट है. along this path the test charge will move. Okay, electric field lines are the path followed by a test charge, and along that path if you free a test charge, in that path a test charge will move. Okay, it is very simple. from positive charge electric field lines निकलता है और negative charge में electric field lines क्या होता है, finish होता है. Okay, if you consider two positive charges, I have considered two positive charges. Okay, then what happens, the electric field lines will look like, the electric field lines will be repelled to each other like this. The electric field lines will be repelled from one another. Here both are positive charge, that is why the electric field lines will be repelled to each other, Okay, and you remember electric field lines do not intersect each other. Electric field line do not intersect. Suppose this is an electric field lines, this is an electric field lines. Okay, suppose P is any point on this field line, and if you draw a tangent at that point, okay, the tangent at point P will give you the direction of electric field at that point. Okay, the tangent at that point will give you what, the direction of electric field at that point. If you consider another point Q here, suppose this is another point Q, and if you draw a tangent at point Q, suppose this is the tangent at point Q, and the tangent will give you what, the tangent will give you the direction of electric field at point Q. Okay, so the tangent at any point in an electric field is the direction of the electric field. Okay, this is our suppose this is our electric field lines. This is what, the electric field lines. Electric field lines means the path followed by a test charge. This is the path followed by a test charge inside an electric field. Okay, here P, Q and R, these are the 3 points. At 3 points electric field, the direction of electric field are different. At point P, the direction of electric field is along this direction. Okay, if you want to determine the direction of electric field, then you draw a tangent at that point. If you want to determine the direction of electric field at Q, then you draw a tangent at this point. That means the tangent at any point is the direction of the electric field at that point. Okay, and you remember, two lines of force do not intersect. Two electric lines of force do not intersect. Why two electric lines of force do not intersect? If at a single point two lines of force intersect, then there will be two tangent at a single point. Okay, there will be two tangent at a single point. That means at a single point we will have two electric field. That means electric field having two direction, which is impossible. At a single point the electric field have a single value. Okay, that is why two lines of force do not intersect. Okay, in next class we will discuss the continuous charge distribution. Okay.